Hello, everybody, and welcome back to BioSC 140 Human Physiology. This is the video for Journal Article Laboratory Report number 4. This video is going to focus, and this assignment focuses on the results section of scientific papers and of your laboratory report. Remember, the main sections of your laboratory report are going to be the introduction, which was last assignment, the results, which is this assignment, and the discussion, which is going to be coming up in a journal article laboratory assignment really soon. So, overview, this assignment consists of looking at the results section for your laboratory report. You will also answer questions for the results in this exercise, and those answers begin to form the framework of that section. This assignment is going to get you, you're going to be done with a good portion of your laboratory report once you're done with this assignment. This assignment, you're going to basically do a rough draft, a framework for your results section. So background, the results section consists of two distinct sections. You need two distinct sections in your final write-up. Two distinct sections. It must contain both text and graphical sections. Your final write-up, your final laboratory, must contain a text section, a type section, and a graphical section to get full credit. The text section should appear first. The number one reason that people miss points in a laboratory report is formatting. This is one that students have missed points on before. This is the graphical section before the text section. The second most common reason is hypotheses. Lack of hypotheses, hypotheses not in the form of if and because. Let's get back to this homework now. This section would explain the data presented in the subsequent tables and figures, along with other points not appearing in the tables and figures. Because we use only one experimental setup, statistical analysis is not practical. Therefore, quantitative changes may be more important than qualitative changes may be more important than quantitative. So what's qualitative? What's quantitative? Quantitative is like a whole number, like 4. It's a quantity, it's 4. Qualitative is like it increased or it decreased. It is generally better to point out trends rather than discuss every point on the graph. Try to make the data come alive for the reader by graphically describing the trends in the data. So, a lot of students get the discussion section mixed up with the results section. The results section, you're going to give hard facts. The discussion section, you're going to analyze those hard facts and describe what the meaning is, the significance is of those hard facts. Example, respiratory rate went from 1 to 2. Respiratory rate doubled throughout the experiment. I'm just making up numbers. Those would be good things for the results section. The result was 1, and then the result was 2, and this was a 100% increase. So 100% increase, that would be a way to make the data come alive. That would be a way to describe a trend, a 100% increase, a 32% decrease. It describes a trend. That's what I mean by making the data come alive and describing how the results is, how the data is, without actually interpreting it. Interpreting from the example I just did would be something like, exercise caused the increase, exercise must cause an increase in respiratory rate. based on this experiment. Their respiratory rate went from 1 to 2, and this demonstrates that when the person exercises, their respiratory rate goes up. You know, that would be like an analysis of it. So maximums and minimums, percent change is another great way. In this experiment, the minimum value that was found was 1. The maximum value that was found was 2. These are ways to make the data come alive in the text section. After that, you should have a graphical section, which consists of tables and figures. Tables and figures. These are used to allow you to paint a picture of the evidence you are presenting to the reader. The general rule for data presentation is to display it in the form that is easiest for the reader to understand. It's going to be different for different people in different experiments. Some experiments, you could use a few different types of graphs and it still displays the data well. But some experiments, pie charts are going to work great. Some experiments, pie charts are not going to work great. For some experiments, line graphs will work great. For other experiments, line graphs will not work at all. Histograms might be the best way. Figure out what the best way to display your data is. Easiest for the reader to understand. This usually takes the form of figures and tables. Each entry should present unique information and should be able to stand on its own. This is a very common reason that people miss a few points on it. Your graphs should be able to be interpreted by themselves. Like if you removed your graph from your final laboratory report, that graph should have a title, it should have units, it should have scales, it should have a sentence underneath it that describes what's going on in that table or graph. Your tables and graphs should be able to stand alone. I'm going to repeat that. This is a common mistake, a common reason that people miss points in the final write-up. Tables and graphs should be able to stand alone, meaning if you remove them from your final write-up, a person could still understand what was going on in that table or graph. Meaning there's a title. It's labeled Table 1. It's labeled Figure 1 with title, changes in heart rate and metabolic rate due to physical exertion. And underneath it, there might be a sentence that further explains, that further clarifies what's going on in that table or graph. So definitely give it a title, definitely label them Table 1, Figure 1. Definitely use your units. It should be a standalone graph. Above, never falsify data. So we are data limited because we're online. We did not perform these experiments. Use the sample data as your data. Yes, some experiments will only have like 2 or 3 data points. Others will have more. You can make it work. Students have made it work in the past. It's still going to work in this semester too. But don't falsify it. Another aspect of understanding scientific research is being able to read and understand the results of an experiment. In this is extremely important detail in the analysis of scientific studies because the data is interpreted to determine the results and therefore any applicability of the study. The most common way to represent data are with tables, charts, graphs, and diagrams. This begs the question. Oh, this reminds me of a question I get sometimes. Tables are where you have like a grid. It's like a grid and you have, numbers and data points within that grid. It's a table. It's like a grid and you put your numbers in the grid. It's called a table. It's got rows and columns. It's got rows of data and columns of data. That's a table. A figure or a graph is going to be like a line graph or a pie chart or a histogram, a bar graph. Always show the data. All right, I think that covers just about everything. Make sure you cover the common errors. And if you have any questions, please reach out to me. Send me an email. Do one more thing. Have a wonderful day.